Limit rules, simple limits. Limit of a constant k as x approaches a is k. For example, limit of the constant 5 as x approaches 3 is equal to 5. The function f of x equals to 5 is shown in the graph. It's a horizontal line passing through 5. As x approaches 3 from both directions, the value of the function stays constant. Limit of the function k as x approaches positive infinity is k, where k is a constant. And the limit as x approaches negative infinity is equal to k, for the constant k. For example, the limit of the function f of x equals to 3 as x approaches positive infinity is 3. And as x approaches negative infinity, the limit of the constant 3 is equal to 3. Limit of the function y equals to x as x approaches 5 is equal to 5. Limit of the function x as x approaches negative 3 is equal to negative 3. The function y equals to x is an identity function as shown here in this graph with a slope 1. Limit as x approaches positive infinity of the function x is equal to positive infinity. Limit as x approaches negative infinity of the function x is equal to negative infinity. If lim denotes any of the following limits, such as limit as x approaches a real number a, or limit as x approaches positive infinity, or as x approaches negative infinity, and if L and M denote real numbers with limit of the function f of x equals to L and limit of the function g of x equals to M, then the limit of the function f of x plus g of x is equal to limit of the function f of x plus the limit of the function g of x, meaning limit of the sum is equal to sum of the limits. Limit of the function f of x minus g of x is equal to limit of the function f of x minus limit of the function g of x, meaning limit of difference is the difference of the limits. Limit of the product of two functions f of x times g of x is equal to limit of the function f of x times limit of the function g of x, meaning limit of product is equal to product of the limits. Limit of quotient of two functions f of x and g of x is equal to limit of the function f of x divided by the limit of the function g of x, and the limit of g of x is not equal to 0. Limit of the function f of x to the power n is limit of the function f of x raised to the power n, meaning limit of the exponent is equal to exponent of the limit, which is equal to L to the n, where n is a natural number. limit of the nth root of a function f of x is equal to the nth root of the limit of f of x, which is equal to the nth root of L. If n is an even number, then we assume L is greater than or equal to 0. Examples: limits of polynomials as x approaches a real number a. Limit of the polynomial 2x squared minus 4x plus 6 as x approaches 2 is limit of each one of the individual terms. Using the rules of the limit of sum or difference is the sum or difference of the limits. Therefore, limit as x approaches 2 of 2x squared minus limit as x approaches 2 of 4x plus the limit as x approaches 2 of 6. This gives 2 times limit as x approaches 2 of x squared, because limit of products is product of limits and limit of a constant is constant. Limit as x approaches 2 of the function x squared is 2 squared, and limit of the function as x approaches 2 of x is obtained by plugging in x equals to 2. The limit of constant is constant. Simplifying this, we obtain the limit of the polynomial 2x squared minus 4x plus 6 as x approaches 2 is equal to 6. Example: limit of the polynomial minus 3x squared plus 2x plus 3 as x approaches 3. The limits of the polynomial are quickly obtained by plugging in the value the x approaches, because polynomials are continuous, and therefore the limit can be obtained by plugging in the value x approaches, as shown here. Limit of the function negative 3x squared plus 2x plus 3 as x approaches 3 is obtained by plugging in x equals to 3 in the polynomial. Therefore, the limit of the function negative 3x squared plus 2x plus 3 as x approaches 3 is equal to negative 18.